Good morning, IM3 students. Today we're going to continue lesson 11.1 and we're going to do day 2, which is just to continue to work with rational and radical expressions and simplifying radicals. Today we're going to be able to translate between radical and rational exponents. And here we go. The first thing we're going to take a look at is a review. Yesterday in the previous lesson, you guys were introduced to taking the radical forms and translating it as an exponent with a fraction. So in the nth root for m, if it's equal to 1, then 1 over n is the nth root. So that's just a review. And if m is not equal to 1, then m is the power of n. M is the power and n is the root. So again, the bottom number tells you what kind of root you're going to have. Square root, cube root, fourth root. And then if a is positive, if n is even, and a can be negative if it's odd. So if you're taking like a cube root of negative a, you will have negative 2, right? But if you're taking a square root of 4, you're going to have 2. So basically that's what this means. And then rational exponents, for any natural number n, integer m, the real number where the nth root of a is real. And the following ways of expressing the exponents m over n are equivalent. So these two right here ways of writing are exactly the same. So applying the power after taking the root is the same thing as taking the power and then taking the root. So they mean the same thing. And converting between the radical and rational form is indicated in this example again, as we have discussed yesterday. So the numerator, again, what's on top goes to the power. So what's on top stays on top again. And then the denominator, tells you what the root is. So it goes outside. And so that's how you can remember, again, what's on top stays on top. And here's a summary again for those two rules that would be the same thing, equivalent, when you take the power after or before. It does not matter, but we will have to see what the situation is. Sometimes it is better to apply the root first. Sometimes it's better to apply the power first. So, we have to be flexible in working the problems. In general, if the number of the base is really big, you may want to do the radical first, like take the root first before you actually raise it to a power. Translate, number 1, translate the expressions with rational exponents into radical expressions. So we're going from rational, which is a fraction power, to a radical form, which will be a root form. So this is kind of like the same thing that we just did yesterday. So what's on top stays on top, and the bottom number is going to be on the outside. So this is going to be a fourth root of 625, and then to the third power. So once again, whether you're going to apply the cube before or after is kind of like depends on the problem. In this case, I would not want to take the cube root first before you take the root, the radical of fourth root. So I would actually take the fourth root, because otherwise if you take 625 and cube it, it's going to be a really big number. So you want to take the root first. So we're going to take the fourth root of 625, and that just happens to be 625 is actually 5 to the fourth power. So if we rewrite 5 to the fourth power and take the fourth root of it and then cube it, what happens is the fourth root and the fourth power cancels out. So you're left with 5 to the third, and now that is a lot easier to simplify, which gives you 125. And likewise, we're going to just try number 2 right now, except you'll notice that there is a negative right there. So we're taking the fifth root, with what's on top stays on top. So the bottom is the root. So the fifth root of negative 243, and then again to the second power. So it seems to be kind of like a habit that I like to always apply the power after the root if it's possible. So negative 243 is actually negative 5 negative 3 to the 5th power. So if we take the 5th root of that and then square that, don't forget the 5th root and the 5th power cancels out. So we got negative 3, and then the square is applied to the whole thing, which means the negative also gets the square. So be careful with that. And we got negative 3 times negative 3, which is 9. And that is the answer for this problem. We're going to continue here and give you 2 more examples. I'm going to do the next one. So we're taking 81 over 16, raise it to the 3/4 power. So what's on top stays on top. So this is going to be a 4th root of 81 over 16, and then raised to the 3rd power. So we're going to actually take the 4th root of 81, and that is basically 3. And then the bottom, the 4th root of 16 is actually 2. And we still have a 3rd power. So we're going to apply the rule that we need to raise both top and bottom to the 3rd power. So 3 to the 3rd is 27 over 2 to the 3rd, which is 8. So that is how we do that problem. Final answer is 27 over 8. I'm going to try the next one. This one does not have values for the base, so we're just going to be very general with the answers here. It is a cube root because the bottom number is 3, so it's a cube root of xy. And then finally we have a 5th power. So remember, the equivalence is just going to be the 5th power goes inside. So that's another way of writing it. And we're just going to leave it as the way it is. But we're going to try to simplify. So the 5th power actually applies to the both base numbers. So it's x and y gets 5th. So let me rewrite this. It's going to be x to the 5th, y to the 5th, and the cube root of that. In this problem, I decided to apply the power inside. So that's why I write so they're the same thing. So the cube root of x, y, and then 5th power, these two are equivalent. So I'm going to just take the first one form and apply the 5th power to both of them. And now I'm going to apply the cube root. So I know that 3 can go into 5 one time. So I can take out 1x, and then I have a leftover, which is I have 2x left over. Okay, because remember, 1x outside equals 3 inside, right? So I got 5 total. So I have 1x, and the same thing goes for y. I can take out 1y, and then I still have 2 left over inside. So this seems to be the most simplified form of this problem. And you guys are going to go ahead and try these 4 problems before we go over the answers. Hopefully you have a chance to try the problems before you look at the answers. So let's see if you got them right. So first we have a square root here of 25 raised to the 3rd power. And again, this problem is easier to apply the square root first because we know that square root of 25 is 5. And then we have a 3rd power. So 5 to the 3rd is 125, and that's the final answer for the first one. Hopefully you got it right. And this is going to be a cube root of negative 27 raised to the 2nd power. Cube root of negative 27 is going to be negative 3, and then square that gives you a 9. Next one, we have a 5th root of 32 over 243, and then cubed. And we know that the 5th root of 32 is 2, and the 5th root of 243 is actually 3. And don't forget, we have a 3rd power, so we're going to cube 2 to the 3rd, which is 8, and then 3 to the 3rd, which is 27, and that is the final answer. And the last one here is going to be taking the c root, because we do not know what kind of root it is, but it's the c, and then 3y to the raised to the b power. So this will be one way of writing it. Remember, there's another way, c root of 3y to the b power, and that's another way of writing it. So either one of them is correct. Hopefully you got everything correct. And now we're going to try 3 more now. And this example, you're going to translate the radical into expressions with rational expressions. So we're going backwards now, and we're going to actually rewrite the base and then the power as a fraction. So we know that the 4th root is, that means the fraction is going to have a 4 on the bottom. What's on top stays on top, so it's 4 to the 2 over 4. Or you can, of course, reduce that to 4 to the 1/2. And we know that 4 to the 1/2 just means it's going to be 2 squared, because 4 can be rewritten as 2 squared. And then we can multiply the 1/2 and 2. Half of 2 is 1, so the final answer is 2. In other words, the square root of 4 equals 2. And the next thing is the same thing. We're going to rewrite the problem as a 6 to the 9 over 3. What's on top stays on top. And that's going to give you straight a 6 to the 3rd power, which means a 216. And that one is pretty straightforward. Next one is going to be just rewriting 2x over y to the 5 over 3rd power. And it does not seem like we need to simplify this any further, so that would be an acceptable answer. I'm going to leave it in that form. And it's time for you to try 3 more on your own, so go ahead and try the problems before you look at the answers. And hopefully you've had a chance to try the problems. Let's go ahead and take a look at the answers. And now the first one is 9 to the, what's on top stays on top, so 2 over 4, and it's going to be 1/2, and 1/2 is just like the square root of 9, which is 3, so the final answer is 3. Hopefully you got it right. And then second one is going to be 7 over 8, 7 to the 8 over 4, which just means straight a 7 squared, and a 49 as an answer. Next one is going to be 1 over 16 to the 3/4 power. And I'm going to actually rewrite the 116 as 1/2 to the 4th power, because 2 to the 4th is 16, right? And then 1 to the 4th is 1. So that's how I'm going to write it. And then I take the 3/4 power. Notice that 4's will cancel out, and I have 1/2 to the 3rd power. And so now I'm going to apply the cubic to both top and bottom. So it gives me 1 to the 3rd, which is 1 over 2 to the 3rd, which is 8. So final answer is 1/8. Those are just some examples to show you how we could work with the radical and the rational exponents. Hopefully that gives you more detail and insights to how to simplify the radical and exponent forms. And that is the end of day 2. Go ahead and log into Google Classroom and find out what is your homework for today. Have a great day.